Hello, Roy here. Today I wanted to share with you a little bit of a walkthrough through the code for the OBS background removal plugin that I had built. I started working on this plugin about 2 years ago when I saw a post of people looking for a solution to do virtual green screen and background removal in OBS where none of that existed. And I said, hey, I can do that, and turned around in a couple of days, and I did. And I started this plugin and put it up on the OBS plugin registry. And since then, it kind of took off. It's been more than 2 years in the making and already received more than 500,000 downloads, which is pretty cool. I haven't done this alone. I had a few contributors working with me, but I kind of wanted to share with you a little bit on how the plugin looks from the inside and kind of how it works, in case you're looking into building a plugin like that by yourself. Or just interested in how this particular plugin works. The very first entry point for any plugin for OBS will be the plugin main CPP file. All the plugins are built in C++ using the very, very good plugin template provided by the good people at OBS, of the OBS project. The OBS plugin template is a very neat template for starting to build your own plugins. It comes with a lot of things built in. Obviously, the plugin that is built in this template doesn't do anything, but it has everything that you would need to publish your plugin, like a whole lot of AI workflows attached to it, like building this for both Windows, Mac, and Linux, with a lot of different actions whenever you release something or you want to put something up as a new version of your plugin. There's a lot of boilerplate code that's kind of like in here. I want to thank very much the OBS people for putting this up, because this kind of enabled my work and getting started really, really quickly with that. I started with an older version of the plugin template, and then they released more and much better versions, and I had to adapt my older plugin to that. But since doing that, we were able to release the plugin now with installers both for Windows, Mac, and Linux, and also have it ready for different distros of Linux. So check that out. Now, what you'll have to do is start implementing the plugin from this file, the plugin main CPP. It basically doesn't do much. It only registers the different functions that your plugin has with OBS and kind of gives it a name, and not many interesting things going on here, except for registering your plugin with OBS. The real meat of the plugin will come in, most likely, in a different file that you make. And for us, this file is called the background filter. And all the way at the end, this OBS source info struct basically defines the functions of your plugin. Video render is where you're rendering your video. Video tech is when you're getting a new frame. Activate, deactivate, creating, destroying, and looking at properties. All of this defines how your plugin behaves when it works on OBS. For example, in here, this is the background remover plugin. It has different properties that you can adjust, and they will affect the rendering of the plugin and the way that the plugin actually renders itself and the way that it blends with the rest of the program. All of that is defined by the plugin registry that's found in this struct. The rendering, the default, the properties, creating, destroying, and disabling, and so on. Let's take a look at a few of the key components of this. The video render. This is where you're actually doing the rendering to the screen, and this is going to use the effects route. There are a few routes of rendering things to screen, but recently we have shifted to working with effects, because these are utilizing the GPU, and they save a lot of CPU cycles, because we're already using the CPU for running the neural network inference. We want to basically move off as much as we can to the GPU. This is in here in the video render. We're basically getting the default effect here from OBS, and this effect really doesn't do anything. It only renders an image to screen, and had to write our own effect in HLSL through the vertex and pixel shaders to render this to screen, but it all is done in this one function here, the video render. We're actually not using the effect given to us by OBS. And here what we would do is that we grab the RGB image from the input from the source of our plugin and grabbing it from the GPU memory rendering system to CPU. And once that is done, the neural network takes it and runs the inference on it. And once we get that, the neural network would run in a different function that we get to, and we need to blend both the input and the output mask, the background mask, into a single image. And this is what we're doing at the rest of this function. Sometimes we blur the background if that's needed, requested by the user. But basically what we are doing is that we're taking the background image, the background mask here, and adding it to alpha texture. That will be just the pixels that are a part of the background or part of the foreground. The pixels that are around the portrait are the background, and the pixels of the foreground of the portrait. This is defined in this binary mask here, and we're setting that up in a texture, and then we're running our own effect here that we wrote that takes in the alpha mask and the input RGB image and basically blends them together. It's a very, very simple operation. This is per pixel. What we're doing is we're getting the color image, we're getting the alpha value, and just multiplying that by the other, and that will actually hide out the background pixels and show only the foreground pixels, where the background pixels are actually going to be completely transparent. This is done in here. This is pretty much everything that this function does. It just grabs the RGB image, sends that to the neural network. It grabs the output of the neural network and then blends these two things together in this one filter, in this one effect here. The next thing to kind of think about is how the neural network is running. I mentioned that the video tick here is when a new image comes in, and that's actually true. Whenever we get a new frame, we're grabbing that RGBA, that input color image, from our graphic system below. And then essentially what we're doing is just running it through the neural network here in process image for background. And once that's back from there, we have a little bit of post-processing, like cleaning up the binary mask and smoothing it and resizing it back to the original size. And that's basically it, because at this point and on, our graphic system will be able to grab this background mask image and blend it with the foreground. That's going to be down on the GPU. The neural network is actually run from this function here in filter model inference. That's going to take the input color image and the settings in our filter, the different models or the different settings that we have, run that and store it in the output image, which is then copied into the background mask in here. Let's see how this is done. The model inference is actually very simple. It only has a few steps. Once we get the RGB image, it's in RGBA, we convert it to RGB, just 3 channels. We're resizing it to the different models' expected input size and running some potential pre-processing that we need to do, maybe removing the average color or changing it to be between 0 and 1 or -1 and 1. It depends. Every model has a different way that they work with their inputs. We're loading it up into the inference session and then running the neural network on it, grabbing the output, potentially doing some post-processing, and then just converting it to the expected output from it. It's not a very difficult to understand sort of process here, but it does hide a lot of the things in here are kind of abstracted by this one model class. Let's take a look in there. We have a few abstract classes that help us wrangle all of the different models that we are potentially could be running. We have many options for different neural network virtual green screen models, and they're all abstracted behind this one parent class model. What this parent class is doing is a few things that are kind of generic for all the models, like getting the file path, because all the models are stored as part of our plugin. All of the ONNX files are provided here. Populating different input and output names for the inference session and the shapes of them, and also allocating those buffers. All of this is shared between all of the models. Where the models differ really is in the input size and the pre-processing and post-processing. Each one of the models have a little bit of a different way that they pre-process and post-process the outputs, and that's going to be implemented in the subclasses. But all of the other stuff is basically abstracted away at this one parent class that really does everything quite well, and you don't have to worry about it. One major difference between the different models is that some models are BHCW and some are BCHW, meaning the channels come first or the channels come last. This makes a big difference really in preparing the input to the network and post-processing, where we would need to transform it between BCHW to BHWC. This is kind of what we have going on in this post-processing. And some of the models will inherit from BCHW and not from the generic model to fit their needs. Getting the network input size and network output also differ a little bit between BCHW and BHWC. For example, the RVM model is using the BCHW, and it's actually doing much more in here because this is a temporal model, and it will actually need to take some of the outputs and put them back in as inputs. But a different model like MediaPipe is actually very nice and short because all it does is a little bit of pre-processing and post-processing that has to do with this particular model, like using the min-max normalization on the output. Once that is run, all of these operations are kind of abstracted by the model classes in here, and this stays very generic, and we don't really update it very much. All we need to do is create more of these models in here. The rest of the plugin, if you look through the code, has to do with what you see on screen where you're using the plugin, like the different properties. We have a lot of properties for this particular effect, like the threshold and some pre-processing and post-processing operations like smoothing and feathering, and using different GPU options like DirectML, TensorRT, or actually just using the CPU, different model selections, and that's just using a list here with different strings, and sliders for other things like the number of threads and blurring the background. A lot of this information can be obtained from the very good documentation for OBS plugins here on docsobsproject.com. Our plugin is actually a source. It's a filter, but it's actually a source as far as OBS is concerned. There's a lot of things covered in this API reference, but a lot of other things are not covered in here. You kind of have to figure out things for yourself. So check this out before you're starting to really implement your plugin. Some of the things to take note of is that you're probably best to activate and deactivate your plugin when people are not using them. In here, there's this eye icon, and when you click it, it's actually going to disable your plugin, disable and enable your plugin. And when people are disabling your plugin, you may want to go ahead and deactivate and stop the operation of your plugin and do an early bailout of different things. For example, if we get a new frame, but the plugin is disabled, we just return here, and we will never run the neural network on this and save up on a lot of CPU cycles. The same happens if we have any sort of problems. We don't have an input image, or the source is disabled, or if anything in initialization did not actually follow through, we would not run the plugin at all. The last thing I want to cover is that our plugin has a lot of data that's kind of carried around between the different functions, right? Functions here like the update would actually get a little bit of data, and we're casting that pointer into our plugin data, because there's a lot of things that we carry between these functions and we need to sync between them. We're using this struct to kind of move things around between these different functions. These are the kind of things that are very specific to this particular filter. We have another filter in here for doing enhancement, and it will have a different set of features, but this is particular for the background remover filter. Every function that gets this generic data would cast it into our struct, and then that struct could be used. And that's actually done in pretty much every function in here, as you would see. All right, this was a very, very quick walkthrough through a couple of places in the code that I think are interesting as far as our plugin goes. I'll try to make more videos to cover more of the parts and more of the actual building of OBS plugins and capture some of the things that we have learned in the few years that we have been building out this plugin. Thanks for watching.